Okay, first part of chapter 10 is learning geometry. There's two links here. Both links, the videos are embedded on my website for you to refer to. There's not a lot for me to do on this. You just need to watch the videos and fill in each circle and definition as you go. So you'll need to have this in front of you as well as watching the videos. Okay, the first part of this is Greek lettering. You're going to see a lot of different angles in this unit. All of them inside or slightly outside the circle. So if we're looking at an angle here, and you need to find angle from those 2 points. In the textbook, they're going to use X, Y, Z. You're also going to see Greek lettering, which you will see in the videos that follow to explain a lot of these. So they might use psi, or theta, or beta. Any of these can be used to describe an unknown angle. So while you'll see X, Y, Z some, you will also see these Greek letters. So just a little refresher here before we move on. Okay, radius. This is in the first video, so there's the 2 links. Make sure you're watching the first video for this. Okay, the next part of the first video is a tangent line. Again, make sure you're paying attention. Pause it, go back and forth as you watch it to add to these notes. Chord as well will be on the first video. Okay, and the next part here will be diameter. Again, still on the first video. Please pay attention. Hopefully you'll remember this from many years of learning what diameter is. Okay, for arc, there's no real definition. You just need to know what a major arc is and what a minor arc is. So make sure you illustrate that on your notes. Okay, and after arc, we have subtended. Again, now we're on the second video. Okay, so make sure you flipped and get all the notes down here. Central angle. Now you're looking at the second video for the last part of this section, so make sure you've drawn it out, you have the definition down. After central, we get to inscribed angle. Both these angles are connected. You're going to see this throughout the entire unit. Please make sure you understand the definition of each. It will make your life a lot easier going forward. Pythagorean theorem. You need to know how to solve this still. So, this is no more videos to watch. You have a right angle. As you went through the notes, you learned what a tangent line is. B to M, I'll draw this as straight as I can, which isn't great, makes a tangent line. B is that point on the circle, so that is a right angle. If you redrew the triangle, here's your right angle. R would be the worst R ever. There's R. 8 is on the height of the triangle, and 10 will be the hypotenuse. So to solve for this, it is a squared plus b squared equals c squared. So 10 will be c, you can call r a, 8 can be b. So radius squared plus 8 squared is equal to 10 squared. Leave r alone for the moment. Add 64. 10 squared will give you 100. Now you want to find r on its own. So we're going to subtract 64 and subtract 64. And the last part now, r squared is equal to 36. Find the square root of that. You get r to equal 6. So your radius here in this circle will be 6. Hey, one more example of Pythagoras. If you need to find the length now of A to B, all the way across. First thing you need to do is find the length of C to B. And whenever we find the length from here to here, we're now obviously just going to double it. So the same rules apply. The angle at C makes a right angle, shown by this box here. So using that, we will again use Pythagoras. So a squared plus b squared is c squared. I'll make that look a little cleaner. A squared plus b squared is c squared. So if we call A is 7, B is that unknown length, and the hypotenuse is 9, we get 49 plus B squared equals 9, that's right, 81. Okay, so from here we are going to subtract 49 from both sides, take the square root, and you're going to get some long decimal calculator. For this unit, when you get a decimal, just round to the nearest tenth, to the nearest 1 centimeter. So for this one, we get B to equal 5.7 centimeters. And then the last step again was to find the length from A to B. So to do that, we take 5.7 multiplied by 2, which gives you 11.4 centimeters. So both of these use Pythagoras. You're going to need to extend your thinking in this unit to see bits of information to get to your final answer. Okay, for nearing the end of this now is angles inside of a triangle or a straight line. To start with inside a triangle, you need to remember that all triangles, the total angles inside will equal 180 degrees. So no matter what shape the triangle is, the three angles always equal 180. So looking at this example, you have this top angle coming off the center at 60. This square here on the bottom means a 90 degree or right angle. So to find x, we will subtract both angles you're given from 180, leaving you with x having an angle of 30 degrees. That's it. As long as you can remember that, you will do extremely well in this unit. Okay, the last part of this is two types of angles. Complementary angles is angles that have a total of 90 degrees. So if we look at x to m to a, that makes a 90 degree angle. So the angles in between, so we've got AMQ, and then we also have XMQ. These two angles must add up to 90 degrees. So if I tell you that AMQ is 34, then to find XMQ, it would be 90 minus 34 is equal to 56 degrees. So that's complementary angles. Okay, and our last part for angles is supplementary angles, where a straight line will be 180 degrees. So if you're given the angle right here, you're able to find the missing angle there. So if I tell you that CFP is 125 degrees, in order to find PFW, 180 minus 125 will equal 55. So the angle right here is 55. Again, once we start looking into 10.1, you are going to see these kind of questions, so please refer back to this when you get there. Okay, this last slide we're not going to worry about, so you can just disregard it, cross it out, and this is the end of the introductory notes to Chapter 10.